Okay, this is section 2.3. So first we're going to go through the prep skills. Now, remember for the video, you can pause it at any time if you want to try to work the problems on your own. I'm just going to go ahead and go straight through everything. Okay. All right. So number one on the prep skills, convert each percent to a decimal. So all we're going to do is find the decimal. So we're going to drop the percent sign and find our decimal, and then we move it two places to the right. So 12% is going to become 0.12. Okay. 4%. Well, the decimal is behind the four, so two places to the left, 1, 2, that's going to be 0.04. And then 2.99%. Well, after we drop the percent, here's our decimal. So two places to the left, 1, 2.0299. And on all of these, you can check by moving your decimal two places to the right to see, make sure that you land back where you started. Okay. All right. Now for number two, it says find each percentage requested. So all I'm going to do is make sure I've got my calculator handy. And so when I multiply this out, we're finding 12%, 12.3% of 100. So I turn this into a decimal. So that becomes 0.123 times 100. And that's going to give us 12.3. Okay. So all we did was 0.123. The word of means to multiply. We're going to multiply that by 100, and that's where we get the 12.3. Okay. All right. The second one, 3.1%. Now this is a typo. This should be $1,183.13. Okay. So point here's our decimal. So we need to, I mean, our decimal from the percentage. We're going to move it two places to the left. So 12.031 times the 1183.13. So 0.031 times, and now this is money. So for money, remember we have to round, you have to do this on your own because I'm not going to tell you to do this. But for money, you round to two decimal places. So 0.67, that second seven is going to tell me to bump up. So my answer is going to be $36.68. Okay, so be careful with your rounding. All right, now in three, they want us to find A from this given formula. So they've given us that P is 5, Q is 120, and R is 0.03. So all we're going to do is plug that in. So P is 5, Q is 120, and R is 0.03. Okay, so I'm going to number crunch this. So 5 times 120 times 0.03, and we get 18. Okay. All right. Now for number four, we have two of these to do. So number four, they want us to use our calculator to uh, compute the computation. So what I'm going to always stress is use your parentheses very liberally. So here's what I'm talking about. You need to be very careful how you enter this in your calculator. If I enter in 50 plus 40 divided by 120, that's what that says, right? And that looks like we entered it incorrectly, then we get this answer. However, I have to be very careful because everything in the top needs to be added before you divide by 120. So I would strongly suggest using parentheses. So the 50 plus 40 is in parentheses, and then I divide that by 120. And notice how our answer is completely different. Okay, and 0.75 is our correct answer. So you need to be very careful with this. Okay, now the second one, you can actually enter this in exactly as you see it. So 1,000, open your parentheses, 1 plus, and then 0.06 divided by 5, close your parentheses. And that's going to give you 1012. Okay. All right. Now, the last two are little equations that we're going to solve. So for number 5, S is being divided by 0.2. I want to solve for S. So the way that I do this is, since S is being divided by 0.2, I undo the division by multiplying. So I'm going to multiply both sides by 0.2. All right. So on the right side, these do not cancel. The right word is they reduce. Okay. And then on the left side, it's just 0.2 times 5, which is 1. So S equals 1. I don't like using S's. They look like 5s, so you got to be careful. Okay, number 6, the way that we're going to begin this is we're going to clean up the right side. So I have 58.20 times R times 3. So that's all being multiplied. So I'm going to go ahead and multiply the 58.20 times 3, and I get 174.6 times R. There's my variable. Now, 174.6 and R are being multiplied. So division undoes multiplication. So we're going to divide both sides by 174.6. All right, so again, the 174.6 on the right side, those are going to reduce. I'm just going to flip this around, put my variable up front. So 4.36 divided by 174.6. Now we have to, obviously we can't keep this answer. We're going to have to round. So I'm just going to tell you, go ahead and round this answer to 2 decimal places. Okay, so let me put this up here. So we're going to round to 2 decimals. Okay, so rounding this to 2 decimals, so 0.02. So I look at the 4, it's not big enough to bump that 2 up. So this just becomes 0.02. Now, I can no longer say that this equals. This is an approximation. So we use our squiggly equal signs to tell us that this is approximated. It's approximately 0.02 because we did have to round it. Okay. All right. Now, learning objectives. Here's what we're going to be working on. We are going to define interest and understand the related terminology, develop simple interest formulas, use simple interest formulas to analyze financial issues. All right. So here we go. So interest is a fee paid for the use of money. For example, if you borrow money from a bank to buy a car, you must not only pay back the amount of money that you borrow, but you also pay an additional amount called the interest for the use of the bank's money. So the bank isn't just going to let you, you know, borrow $24,000 so that you can buy a car and then you pay them back, within a certain time period, and that's it. The bank is going to want some money, more money from you. Okay. And so that is interest. And we're going to learn how we calculate the interest on different types of purchases. Now, on the other hand, if you were to go to a bank and deposit money into an account, then the bank will pay you interest for saving money, since it will be using your money to provide loans, mortgages, and so on to people who are borrowing money. So when you go to the bank and deposit a certain, let's say you have $5,000 and you're going to deposit that into an account at a certain interest rate for a certain period of time. Well, the bank's way of saying thank you is that you earn the interest. So you're going to get back at the end of that time period, you're going to get back more than the $5,000. You're also going to get back whatever interest you earned. Okay. So, on one hand, the interest can work for you, but on the other hand, it can definitely work against you. The stated rate of interest is generally given as a yearly percentage of the amount borrowed or deposited. And we'll get into that in a little bit. We'll get into that in more detail. Okay. All right. So let's look at, excuse me, let's start looking at our content. Okay, there are two kinds of interest. Simple interest is paid strictly as a percentage of the original amount of money. Let's read that again. Simple interest is paid strictly as a percentage of the original amount of money. Compound interest is a percentage of an original amount as well as a percentage of the new amount, including previously calculated interest. In this section, we are only concerned with simple interest. We're going to look in the next section, 2.4, we're going to look at compound interest. And there is a big difference between the two. Okay, so for right now, all we're going to be doing is looking at simple interest. Okay, so let's say that you get a $600 tax refund and you wisely decide to put uh you wisely decide to put it into a long-term investment that pays 5% in simple interest each year. How much money would that add to your account each year? Okay, so what they're asking is they want to know basically what is 5% of 600? This is what they want to know. Okay. Now, 5%, 5 per 100. So 5 for every 100. Well, if you have 6 100s and you compare it to 5 over 100, then 5 times 6 is going to be 30. So that means this would earn you 5% of 600 is going to be $30. Okay. And that's how much you would uh, add to your account each year. Now, again, simple interest is paid strictly as a percentage of the original amount of money. So you put the $600 in and you earned for each year, you're going to earn $30 in interest. Okay. Now, write out the multiplication that you did to get your answer from the previous example. All right, so the next goal is that we write a general formula for computing the amount of interest earned. Substitute the letter P for the original amount invested and the letter R for the percentage you multiply it by. All right, so what did we do? Well, we basically took 600 and we multiplied it by the 5%, which we write as a decimal. And that's what gave us the $30. Now, they want some kind of formula. Well, P is going to be the original amount invested, which is the 600, times R is the interest rate that we invested at, and then we earned our interest. So interest is principal times your rate. Okay, real easy to find, right? All right, now let's look at this next example. Fill in the following table, which shows the growth of the account over several years, as well as the total amount of interest earned. Remember that this is simple interest, so the interest earned each year is always calculated on the original value of the investment. So when we start, well, there is no calculated interest. There is no interest earned. We have no interest to add to our principal, which is the amount that we're investing. So the only thing that we have in our account at the very beginning is the $600 that you deposited. Okay. Now, after year one, we're going to calculate our interest. All right. So how do we calculate our interest? Well, we just did that. So it's your principal. We did that in example 2. It's the principal times the rate. Now, our principal is what we are investing, which is the 600, and our interest rate is the 5%. So, since we already did that calculation, it's just 600 times 0.05, and that's going to give us $30. Okay, so after year one, how much interest have we accumulated? Well, we have accumulated $30. So now I'm going to take that amount of interest that I earned, not the accumulated. This is total interest earned. So this is going to be a running tally. We're going to see this interest value grow. So this is what we're looking at. So we're going to take our calculated interest, which is the $30, and we're going to add it to the principal, which is 600, and that's going to give us $630. So at the end of year one, here's the $600 that we invested plus the $30 that we earned from our interest. Okay. Now, after year two, well, I'm going to calculate the interest. Now, remember, simple interest, I'm going to be reminding you about this. Simple interest is paid strictly as a percentage of the original amount of money. Our original amount of money is the $600. So that means this is going to be 600 times 0.05, which we already know is going to be $30. So now, after year one, we earn $30. So here's that amount that we earned in interest from year one. At year two, we just earned another $30. So that means this is going to become $60. Okay. Now, I'm going to take the $30 that I just earned, which I meant to write this in red. So the $30 that we just earned, okay, for my interest, and I'm going to add that to the amount that we previously had in our account, which was the $630. So now that's going to give us in our account, we now have $660. Okay. All right. Now for year three, we're going to do the same thing. It's our principal times the interest rate, which is $30. So we've earned $30 for year three. Now, how much have I earned in interest so far? Well, year one was 30. Year two, we earned another 30. So that's 30 and 30 is 60. Year three, we just earned another 30. So this is going to be $90. Okay. Now, how much interest did we earn after year three? That was $30. And then I'm going to add that to the previous amount that I had in my account, which was the $660. And that's going to give me $690. Okay, I'm going to do this again. And I'm going to just kind of fill this in because I think hopefully you are understanding what is happening here. So we take the interest that we earned after year four, and we're going to add it to the $690 that is now sitting in our account. So this gives us $720. Okay. Then after year five, well, again, 600 times 0.05. Okay. Here's the interest that we just earned from year five, plus the previous amount in our account, which was the 720. So now we have $750 in our account. Okay, now all of a sudden it jumps. Okay. Now hopefully you can see what happens. So every year you are earning $30. Okay. So at the end of 5 years, you have earned a total of $150. So how much are we going to have? So the calculated interest here for after 10 years, this is going to be, now look, it's going to be another $30, right? After 10 years, notice this part doesn't change. It's this part, the total interest earned. So at 5 years, you've earned $150. Well, after 10 years, so you can see what's going to happen. So after 10 years, this amount's going to double. So that means that's how much you have earned so far in your uh, interest that's been accruing. Okay, now after 10 years, well, that's going to be 150 plus the 750 that we already have had in there, and that's going to give us $900. Okay. All right. Now it would be pretty mean of me to make you fill a table like this out, to make you fill out a table and carry this out all the way to 10 years because we didn't calculate year 6, 7, 8, 9, and 10. Okay. So that would be pretty mean of me to do that. But you can see how the pattern works. Okay. Again, simple interest is strictly a percentage of the original amount of money. Okay. All right. Now we have some terms that are very important. Interest is the fee charged for the use of money. All right. Principal is and that's P. We use P to denote, I to denote interest, P for principal, is the amount borrowed or placed into a savings account. R, little r, is why did that say recent? That should say percent. Okay, sorry, that's a typo. Is the percent of the principal paid for having money loaned or earned for investing money. Unless otherwise indicated, rates are given as a percent for 1 year. Okay, that's going to be important. Time, little t, or term is the length of time that the money is being borrowed or invested. When the rate is given as a percent per year, time must be written in years. And that's also going to be key that you take note of how time is given to you. Then the future value, we're going to denote it with the variable A, is the amount of the loan or investment plus the interest paid or earned. So that's how much are you going to end up uh, getting back out from the bank if you deposited so much after a certain time period, okay? Or that's how much are you going to owe when you have to pay all that money back, okay? All right. So now from the work we did in examples 1 through 3, the principal was $600, so P is 600, and the rate was 5%. Written as a decimal is going to be R equals 0.05. The amount of time varied when filling out the table of interest, and so did the future value. Okay, and again, you see that's exactly what happened. So our interest, the amount of interest that we earned, you can see that it varied depending on the year, and so did the value in your account. Okay. All right. So it says in example 2, you should have discovered that the formula for computing interest in 1 year is P times R, which we did. That's what we just did. It says use this to write a formula for finding the amount of interest that accumulates in T years. Well, if interest is principal times rate, then this was done for each year. Okay. So if I want to know, well, what is my interest going to be after 40 or 50 years, then all we have to do is multiply that by T. Okay. Now we did kind of multiply this by T. We just didn't really make a note of it. So here's our principal times the rate. Now our time since we were calculating this at the end of every year, our time was 1. So if we multiply by 1, then I don't really have to show that I'm multiplying it by 1 because 1 times anything is itself. Okay? So there really is a 1 at the end of all of these. Okay? Principal times rate times time. Okay. Now, number 2, it says the total value of the account after T years is calculated by adding the total amount of interest to the principal amount. Use the formula you just wrote in question 1 to write a formula for the total value in terms of P, R, and T. Remember, we're using the letter A to represent the ending amount and calling it the future value. Okay, so what did we do? Well, let's again go back to your chart. So we calculated our interest, principal times rate times time. Okay. And then we took that interest and we added that interest to our principal. So if this is P times R times T, that's what this is, P times R times T plus P, which is the amount of our principal. Okay. So what they're trying to get you to see here is A is going to represent your future value. So if you take your principal and you add the interest, let me just write I, okay? Well, how do we calculate simple interest? Well, we take the principal times the rate times the time. And that's the formula that they're looking for, okay? Now it says use the formula you wrote in question 2 to find the future value of your original $600 investment at 5% interest in 30 years. Okay, so they want us to take this formula, A equals P plus P times R times T. All right, well, remember P is 600, R is going to be 0.05, and then T is going to be 30. And so we're just going to plug in. So A equals 600 plus 600 times 0.05 times 30. Okay. And then we're going to use our calculator and we're going to number crunch this. All right. So 600 plus 600 times 0.05 times 30. And that's going to give us $1,500. Okay. That's how much that will be in our account after 30 years. Okay, so the right side of your answer to question 3 should be the sum, meaning that it has 2 terms, sum, you're going to add. Use some algebra to rewrite the formula so that you just have one term. The results should look like the principal amount P times some quantity. So here's what they're saying. We're going to do, again, we're going to do some algebra. Okay, so they want us to start with this formula. Okay, now I notice here's a term and here's a term, and notice the P is common. So I can factor out a P, and I'm left with 1 plus R times T. Now, how do I know I did this right? Well, if I multiply this back through, if I multiply the P, in other words, if you distribute, so P times 1 is P plus P times R times T is P times R times T. All right. So this is what they wanted. That's one term. Okay. This is 2 terms because there's a plus sign that separates the 2 terms. Now there's a plus sign here, except the multiplication wins out. So that means all of this is 1 term combined. Okay. All right. And then at the bottom of the page, so here's the summary of the formulas that we just talked about. All right, so your interest, simple interest, is principal times rate times time. The future value we call A. You can either use P plus I, or you can use this amount. Okay. Now, I want to reiterate, notice this step here. Okay. And notice where it came from. So if we look above, the way that you find your future value is you take however much you deposited in that account plus the amount of interest that you earned. Now, how much interest, how do you know how much interest you earned? Well, you have to calculate that. So interest, simple interest, is principal times rate times time. So you take the interest and you add it to your principal. Okay. So that's where the A equals P plus I comes from. And then I showed you how we got this final step. So if you want to do it in 2 steps, this is what you do. If you want to do it in 1 step, then you use this formula. All right. Okay. So let's flip over. It says to meet, example 4, to meet payroll during a down period, United Ceramics Inc. needed to borrow $2,000 at 4% simple interest for 3 months. Use the formula to find the interest they paid and the future value at the end of the 3 months. Hint, how many years does 3 months correspond to? Okay, so there's 2 questions. So the first thing that they want to know, and I'm going to do this I'm going to color code this. So the first thing that they want to know is use the formula to find the interest that they paid. Okay, so interest is principal times rate times time. All right, so principal, they needed to borrow $2,000. So that's their principal. They're going to have to pay that back at an interest rate of 4%, which is 0.04, and then time is 3 months. Now, here's where I have to be careful. They told me that my interest rate, if we look back, here it is. So look at the rate. Unless otherwise indicated, rates are given as a percent for 1 year. Rates are given as a percent per year. But here, time is in months and it doesn't match the years. Well, this is easy to convert. 3 months, anytime that you're given months, if you'll divide it by 12, because there's 12 months in 1 year, okay, that will give you the right value. So let me show you the math behind it. So 1 year over 12 months times the 3 months. Okay, so you can see that your months unit is going to reduce. So that's just going to leave you with T to be 3 over 12. Now, I know that a bunch of you are going to immediately go to your calculator and get that decimal. And let me just tell you, you are going to be very lucky when you do this because you get a decimal that stops. Okay, but what if this was 5 months? Then that would end up being 5 over 12. And then you end up with this decimal that keeps going on and on and on and on. And what you have to do is you have to keep your numbers exact. You don't do any rounding until the very end. So what am I saying? I'm telling you that if you get a fraction, you can check to see if it's a decimal that will stop on its own. If it is, great, you can use it. If it's not, then you have to leave it as a fraction. Now, you're going to be using your calculator, and who cares at this point if 3/12 can be reduced? Okay, it doesn't matter. So to calculate our interest, that's the principal, 2,000 times the rate, times the time. I'm just going to enter this in as 3 over 12 because I don't care that it can be reduced. And then when I number, let the calculator number crunch it for you. All right. So the amount of interest that they will have to pay, or the amount that they're going to pay back, is $20. Okay. Now they want to know the future value at the end of the 3 months. So the future value at the end of the 3 months, that's A. So let's flip back. So remember, you had two options here. You can either use A equals P plus I, your interest, or you can just plug in one time and get an answer. Okay, now, because they forced us to answer the interest question, then I'm going to go ahead and just use P plus I. So here's the principal of $2,000 plus the interest that they're going to have to pay back. So at the end of the 3 month period, they're going to have to pay back $2,020. So these are your two answers. Here's your interest, and then you have your interest for the that other the future value, excuse me. Now, let me just show you. If I had used the formula A equals P times 1 plus R times T, I'm going to plug everything in. Okay. Now, when we did this, actually, we should be using a bracket because we've got some parentheses inside. Okay, so I'm going to enter this in exactly as I see it. 2,000, open your parentheses, 1 plus, and then open 0.04 times 3 divided by 12. We close that parentheses, and then we close the big bracket one. And notice that we still get the same amount, that 2020. Okay, so you could have used either one. Okay, but this probably would have been easier to do anyways because we had to calculate the amount of interest. Okay, next one, example 5. A biotech startup borrowed $68,000 to buy lab equipment at 9% simple interest for 1.5 years. If the loan is to be paid off in equal monthly payments over the life of the loan, find the monthly payment. Okay, so what are we going to do? Well, the first thing that I need to know is how much am I going to have to pay back? So I need to know the future value of this account. All right. So here's the P. They borrowed $68,000. And I would strongly suggest that when you get to these problems that you identify what P, R, and T is. Okay. R is the interest rate, 9%, so that's 0.09. Now, here, they're going to borrow the $68,000 at 9% simple interest for 1.5 years. Well, if you want to say 1.5, because that's 1.5, you are perfectly okay to do that. I would probably do that. Okay. All right. So future value, A equals, now I'm not going to do this formula for my future value because I don't know what I is to be able to add back. And I don't want to have to calculate it. All I want to know is how much am I going to have to pay back? So I'm going to use this formula, the principal times 1 plus R times T. All right, so here we go. So we're going to have 68,000 times 1 plus the rate, which is 0.9, times the year, which is 1.5. Okay. All right. And then I'm going to crunch this in my calculator. So 68,000, open your parentheses, 1 plus, then 0.09 times the 1.5, close it. And so this is how much we are going to have to, they are going to have to, they are going to have to pay back $77,180. Okay. Now, why did I have to find that out whenever they wanted to know what are the monthly payments? Well, again, we need to know how much we have to pay back. Now, to find equal monthly payments over the life of the loan, now, now I have to figure out what am I going to do? Well, I know that if I divide that by the number of months that are in this time period, then that will tell me what my monthly payments will be. All right, so my monthly payments, and when you do any of these calculations, you always want to make sure that you're telling me what it is that you're calculating. Here I used A. That tells me that you're looking for the future value. Now I'm finding my monthly payment. So I'm going to take the 77,180 and I'm going to divide it by the number of months that are in this time period of 1.5 years. Well, 1 year would be 12 months. And then the half a year, that's going to be 6 months. So 12 plus 6 is 18. Okay. So let me just put this months. Okay, so this is going to be 18 months. So we're going to divide this by 18 and we're going to get an approximation here because this is not going to be a nice number. Okay, so the 77,180, I'm just going to divide it by 18. Okay, now remember, this is money. This is money. So we're going to round, and that's why we have the approximation. So our monthly payments are approximately $4,287. Be careful when you round, and 78 cents. Okay. And this is the answer. That's what they wanted to know. Find the monthly payment. So we just did. All right. Now, example 6. Philips Health and Beauty Spa is replacing one of its workstations. The interest on a loan secured by the spa was $93.50. The money borrowed at 5.5% simple interest. The money was borrowed at 5.5% simple interest for 2 years. What was the amount that they borrowed? So this is telling me they want to know what is the principal. Okay, so let's write out what we know. The money was borrowed at this 5.5% simple interest. Okay, so R is 0.055. T is going to be 2 for 2 years. Okay, so they're giving me that the interest was $93.50. Okay, well, interest, my simple interest formula is principal times rate times time. And do I have all of this information? Well, I have the interest rate, which is this. It's the 93.50. I'm sorry. Uh, that's not an interest rate. I have the amount of interest, okay, which is 93.50. So 93.50. My p-value, that's what we're looking for. I know that the rate is 0.055 and the time is 2. So we just did a calculation like this in our at the very beginning. and it was kind of shuffled around, but this is it. This is a calculation. That's why they gave that to us at the beginning as our prep skills. Okay, so I'm just going to take 0.055 times 2. That's 0.11. So 93.50 equals 0.11 P. Now I have to solve for P, so I'm going to divide both sides by 0.11. So 93.50 divided by 0.11, and that gives us, sorry guys, I didn't realize I was off camera. So I did the 93.50 divided by 0.11. So this is going to give me a principal P of $850. Okay, $850 was the amount borrowed. Okay, and here's our answer. All right, now 7A and 7B. After receiving an inheritance, a newly married couple invested $15,250 for 10 years and received $9,150 in simple interest. What was the rate that the investment paid? Show all your work, write your answer in the form of a sentence. Okay, well, that's very similar to what we just solved. So I have the principal, there's the P, here's T, and this is my interest amount. So if I start off with I equals PRT, well, let's plug in what we've got. So 9150 equals, the principal was the 15,250. I don't know what R is. That's what I'm looking for. Times T is 10. Now, this is what the problem in the prep skills looked like. So we're going to multiply the 15,250 times 10. Okay, so we get this, which I don't know why I punched that in my calculator. All I had to do was add a 0 at the end. Okay, now we're going to divide both sides by the 152500. Okay, so our rate is going to be approximately, so 9150 divided by 15, 152,500, and that gives us 0.06. Now that's our decimal. Oops. So, and it stopped on its own, so it's going to be exact. So our rate was 0.06, and then we have to turn that decimal into a percentage. So that's just going to give us 6%. Okay, good. Now, if that couple had been able to find an investment that paid 9% interest, how much more quickly would they have made that 9150 in simple interest? Okay, so now they want us to look for time. Okay, so uh, let's see. All right, so using what they gave us previously, the principal was 15,250. They're giving us a new rate. Well, here they're giving us a rate where before we had to find it. So the rate is 9%. So that's going to be 0.09. And the amount of interest is still going to be the same, the 9150. Okay, so I equals principal times rate times time. And so we have the 9150 equals 15,250 times 0.09. We're looking for T. All right. So I'm going to multiply 15,250 by 0.09, and that's going to give me $1,372.5. Well, $1,372.50. And then we divide, we have to solve for t, so we divide both sides by that amount. Okay, so the 9150 divided by 1372.50, and that gives us 6 2/3. That's 6.666 repeating. Okay, so 6.6 repeating, 6666666, that's the same thing as 2/3. Okay, because uh, if you take 2 divided by 3, then you get that 0.6666666. Okay, that's where that comes from. All right, now 6 2/3. Well, let's see. Are we in months? Are we in years? What is our unit? So the first one was in years. And so, uh, because remember at the beginning, unless otherwise stated, that your interest rate is always going to be in years. It's referring to years. So we know that this answer is going to be in terms of years. Okay, so 6 2/3. Well, 2/3 of a year, if I divide my year into thirds, that's every 4 months. So 2 of those is going to be 8 months. So 6 years, this means 6 years and 8 months. Okay, why do I have to know that? Well, to answer the question, it said, how much more quickly would they have made that interest? Well, 10 years minus 6 years and 8 months. So that would be 3 years and 4 months. So it would have been 3 years and 4 months quicker, faster to earn the $9,150. Okay. So these problems are not just enough for you to solve for the variable, but more than likely they're always going to want something else. Okay. So be careful how you answer. Be careful whenever you read through this problem. Make sure that you're answering what they want. All right, guys, that's it for this section. Let me know if you have any questions.